Hello friends, I am Krishna Mohan Patel and I am working as an instructor, developer, researcher.
A simple linear regression is basically this formula where y equals b0 plus b1 times x. And you might recognize this formula from back in high school. It's just a formula of a trend line or a sloped line on a xy axis. And let's go through these variables and coefficients one by one. So this is the dependent variable. The dependent variable is something you're trying to explain. For instance, how does a person's salary change with the years of experience that he has? So in that case, y would be the dependent variable. Or what grade does a student get depending on how much time he's put into studying? In that case, y would be the dependent variable. So something that you're trying to understand how it depends on something else. X is your independent variable. In this case, in the simple linear regression, we only have one independent variable, so we don't even have to call it x1, we could just call it x. And this is the variable that is, you're assuming that it is causing the dependent variable to change, or as we will learn further, sometimes that independent variable might not be a direct causal factor, but it's still, there might be an implied association between the two, and in that case, you're trying to figure out this association. Then b1 is a coefficient for dependent variable, and it kind of says how the effect or how the change in x1 is unit change in x1 and unit change in x1, how that affects the unit change in x1. So it's kind of, think of it as translator, the multiplier, something like that, that connects to a connector between y and x1. So you can't just say x1 directly. There is, or you can't just say y, the change in x is always equal to 2. There might be this coefficient or change translated to 2. And b0 is a constant, so it's a constant term. So now let's look at this regression. It's the easiest one to discuss. So here we got the y and x axis. Let's look at that as we have experiences. So experience will be our local axis and salary. We want to understand how salary depends on their experience. Well, what we do in regression, we don't just follow here. We look at the evidence, we look at the live hard facts. So here are some observations we had. So in a certain company, this is how salaries are distributed among people who have different levels of experience. And what a regression does is, so that's the formula for regression. In our case, it will change to salary equals b0 plus b1 times experience. And what that essentially means is just putting a line through your chart that best fits this data. And we'll talk about best fitting in the next tutorial when we're talking about ordinary least squares. But for now, this is the chart, this is the line that best fits this data, and even looks like it, right? So it's quite hard to draw a line that fits this data better. And the assumption here is it's impossible. This is the best line that approximates this data. What does that mean? Well, we'll talk about that in the next tutorial once again. For now, let's focus on the coefficients and the coefficient and the constant. So what does the constant mean here? Well, the constant actually means the point where the line crosses the vertical axis. And let's say it's $30,000. What does that mean? Well, it means that when experience is 0, so when, as you see on the horizontal axis, when experience is at 0, then in the formula on the right, you can see that the second part, b1 times experience, becomes 0. So salary equals b0. That means that salary will equal to $30,000 when a person has no experience. So as soon as somebody's fresh from university and joins this company, most likely they will have a salary about $30,000. There will be some confidence intervals there, but we won't go into that right now. Just we can say that according to this model, that person will be probably getting paid $30,000. Now, what is B1? B1 is the slope of the line, and so the steeper the line, the more you get, more money you get per extra year of experience. Let's look at this in this particular example. Let's say somebody went from I don't know, maybe 4 to 5 years experience, right? So then to understand how his salary will increase, you have to project this onto the line and then project that onto the salary axis. And you can see that here, for 1 year experience, the person will get an extra $10,000 on top of his salary. So if the coefficient B1 is less, then the slope will be less, and that means the salary increase will be less per every year of experience. If the slope is greater, then that means the experience will yield a more increase in salary. And that's pretty much it. That's how a simple linear regression works. So the core goal here is that we're not just drawing a line theoretically that we came up with somehow. We're actually using observations that we have to find the best fitting line. And what a best fitting line is, we'll talk about that in the next tutorial. In the previous tutorial, we talked about the linear regression being a trend line that best fits your data. Today, we'll find out how to find that best fitting line, or in fact, how the simple linear regression finds that line for you. So here's our simple linear regression, the same chart, salary versus experience. We've got these red dots which represent the actual observations that we have in our data, and we've got the trend line which represents the best fitting line, or the simple linear regression model. So now let's draw some vertical lines from the actual observations to the model. And let's look at one of these specific examples to understand what we're talking about here. So here you can see that the red cross is where that person is sitting at in terms of salary. So let's say this person with 10 years of experience is earning $100,000. Well, the model line, so the black line at the bottom, it actually tells us where that person should be sitting according to the model in terms of salary. And according to the model, it should be a bit lower. It should be somewhere where that green cross is, which is about maybe, let's say, $80,000. So now the red cross is called YI, so Y with the subscript I, and that is the actual observation. The green cross is called YI hat, and that is the modeled observation, or the modeled value. So basically, with that level of experience, where would he be? Where does the model predict that he would be earning? And so the green line, therefore, is the difference between what he's actually earning and what he should be earning. So, or not should be, what he's modeled to be earning. So therefore, the green line, it will be the same regardless of what dependent variable you have, whether it's salary, whether it's grade at school, whatever. So it's the difference between the observed and the modeled for that level of independent variable. Now, to get this best fitting line, what is done is you take the sum, you take each one of those green lines or those distances, you square them, and then you take the sum of those squares. Once you have the sum of the squares, you gotta find the minimum. So basically, what a simple linear regression does is it draws lots and lots and lots of these lines, these trend lines. Well, this is like a simplistic way of imagining it. The linear regression draws all these all possible trend lines through your data and counts the sum of those squares every single time, and it records it somewhere in a temporary file or something like that, and then it finds the minimum one. So it looks for the minimum sum of squares. It finds a line which has the smallest sum of squares possible, and that line will be the best fitting line, and that is called the ordinary least squares method. So that's how the simple linear regression works, and I look forward to seeing you on the next tutorial.